Today we're going to look at lesson 3.3, function notation. Now the word function you've heard before. Who can tell us what we learned last week about what a function is? Every input, there is exactly one output. So the question today is not, are these functions? These are functions. We're already being told that. We already know that. Okay? But the essential question says, how can you use function notation to represent a function? So the first thing I want you to do today is I want you to highlight where you see this F and then this X in parentheses. This is function notation, and you need to be able to recognize that from here on out, okay? This is called function notation. Now, here's how we read it. It reads F of X. Let's talk about why that's how you read it. If you look at the F in the parenthesis, there's nothing in between it, which is what operation? Multiplication, okay? And if you think back to what you learned in the past, the word of represents what operation? Multiplication, okay? So we don't read this as F times X. We read it as F of X. Now, another thing you need to know, any letter can replace F. Any letter in the alphabet could be in place of F. It doesn't change the fact that it's function notation. Now, I do want you to write these down because these are the most common. You will see F of X, you will see G of X, and you will see H of X most commonly. All right? So F of X is function notation, but if they replaced it with a G of X or an H of X, it's still function notation. All right? And the last thing, and probably the second most important thing you're going to learn today, F of X is the same exact thing as Y. So I can take a problem that's written F of X equals 2x plus 3, and I can rewrite it as Y equals 2x plus 3. F of X and Y are interchangeable, and that's going to be really important when we start to graph these functions today. All right, now look at example number 1. Here's a word that you haven't seen this year, but I do believe you've seen it. Evaluate. When you're asked to evaluate something, what are they asking you to do? Does anybody remember? Solve. To solve. Very good. To solve. Okay, if you don't remember that, add that note. Evaluate means to solve. I truly believe that half the battle of math is if you don't understand the directions, you don't really know how to do or start a problem. So make sure you understand the word evaluate means to solve. It says solve the function for the given values of x equals -4, 0, and 3. Now, we've done this already. Do you remember last week when we learned about dependent and independent variables and we had the guacamole and the avocado problem? Remember, we took the batches of guacamole, plugged them into the function, and found out how many avocados were left. We are going to create that exact same type of graph in order to evaluate this function. Now, before we do anything though, I want us to rewrite letter A. We just learned that F of X is the same thing as what letter? So let's rewrite this function just to show that these two equations are exactly the same. Whether we put F of X or we put Y, we're looking at the exact same function. Now, we create our chart. We've got our X column. We've got our function column. And then, of course, we've got our Y column where our answers will go. They have told us what to use for X. What are the values they want us to use for X? -4, 0, and 3. Now, before we go any further, these are our X values. What's another name for our X values? We learned this last week. Our input, very good. Or our what?
Our independent or the...
It's a D word, yes. What is it?
Domain.
Domain, very good. I love that you guys are trying, okay? Remember, there are X values, there are input values, there are domain, okay? There's 3 different things we can call those. But we're using -4, 0, and 3. Now remember last week we talked about this too. We're going to plug our numbers into the function in parentheses. Why? Because that's a 2 and an X. Side by side. What are they asking us to do to 2 and X? Multiply. So we plug our values in parentheses, so we hopefully don't forget to multiply. So y equals 2 times 4 minus 5. Y equals 2 times 0 minus 5. And y equals 2 times 3 minus 5. Now, order of operations. Are we going to multiply or subtract first? Multiply. So let's work through these. 2 times -4 is what? -8, and -8 minus 5 is -13. Awesome. What's 2 times 0? 0 minus 5? Negative 5. And 2 times 3? 6 minus 5?
1.
1. So all you need to do is box in the entire chart, because I can very easily see you used the right x values, you plugged them into the function, and I can see what your y values are that came out. For problem B, we're going to leave the g of x as g of x. So we have x, our x column. We have our g of x equals the opposite of x is how you read that. Okay, negative x might be how you naturally think to read it, but it actually reads the opposite of x minus 1. And then we're just going to make our last column our g of x column, which is the same thing as which variable? Y. All right. Now we're using the same x values, negative 4, 0, and 3, and we're plugging those in. Now, this is what I was telling you guys before. Be very careful. There is a negative in the function. So the negative in the function has nothing to do with the negative next to the 4. So it's g of x equals the opposite of negative 4. Here's another reason we plug our numbers in parentheses. Minus 1. G of x equals the opposite of 0 minus 1. And g of x equals the opposite of 3 minus 1. Now, what do you see in the very first function? We've got two negatives with the only thing between them being a parenthesis. What do we call that? Double negatives. And what happens to double negatives? They both become positive. So we now have 4 minus 1, which is what? 3. All right, there's no such thing as negative 0. So what's 0 minus 1? Negative 1. And we have the opposite of 3, or negative 3 minus 1, which equals what? Negative 4. And again, we're going to box that in. Moving on to example number 2. It says find the value of x so that the function has the given value. Now again, pay attention to the directions. These directions have asked us to find the value of x. So if you reach the end of this problem and you've solved for y, please recognize that you've done something wrong. All right? They're asking us to solve for x. So let me show you where the mistake comes in typically. If you look at letter A, we have a function, f of x equals 6x plus 9. And then on the other side of the semicolon, it says f of x equals 21. Here's what people see. They see x equals 21. And so they take the 21 and they go plug it into the function in place of x. But guys, is that what they're telling us that 21 is equal to? No, okay? So let's rewrite the functions. Again, just to give us a visual of what's happening. F of x can be replaced with which letter? Y. So y equals 6x plus 9. Draw your semicolon, and then y equals 21. So you see it a little easier when you're looking at it like this. Y equals 6x plus 9, and they're telling us that y equals 21. So we go to the equation and we plug in place of y, we plug a 21, and it equals 6x plus 9. Now look at this. We have an equation to solve. What chapter did we learn solving equations? 1. And we are now in chapter 3. So remember, I keep telling you, math, algebra, it builds upon itself, and we keep bringing concepts along. Here's a perfect example. What's the first thing I'm going to do to get x by itself? I'm going to subtract 9. Very good. So 21 minus 9 is 12. It equals 6x. And how am I going to solve for x? Divide both sides by 6. We've already talked about how we can go ahead and switch the variable to be first, and x equals 2. Now, that's what the directions asked us to do. They wanted us to solve for x. If we had finished and said y equals something, we should look and know that we've done something wrong. All right, now let's move right to letter B. Let's leave it as h of x this time. But do you see the difference? Here's the function, and here's them telling us what h of x equals. So where, Joshua, are we plugging the negative 7? In place of h of x. So in place of h of x, we're plugging in negative 7, and then we're bringing down equals 2/3 x minus 5. Very good. Just make sure you understand, they're not giving us the value of x, they're giving us the value of h of x. All right, Anj, what are we doing first to solve this equation? We're adding 5 to both sides, which is negative 2 is equal to 2/3 x. Maya, we're trying to move a fraction, right? What do? multiply both sides by the reciprocal. Maya, what is the reciprocal? 3 over 2. Now we know 3 over 2 times 2 over 3 on the right side. It simplifies to a 1 that we don't need. So we can just bring down the x equals. Be careful on the left. Negative 2, if we wanted to write it as a fraction, would be negative 2 over what? 1. Okay. Do you see anything that will simplify before we multiply? The 2's. All right. Over 1. We said the 2's would simplify. Be careful though. That is a negative 2 that has simplified to a negative 1. So when you multiply, what do you get? Negative 3. All right. And you box in your answer. Now that leads us to example 3, which says graph the linear function. Here's where the fun begins. Okay. We are graphing a linear function, which means when we are finished, what should these graphs look like? A line. Desiree, thank you. If it is a linear function, what are the first 4 letters in the word linear? Line. So if you finish these graphs and they are not straight lines, you have done something wrong. Okay? Now there are 3 simple steps to graphing a linear function. And understand, these are not going to be written down on your quizzes and tests. So I would highlight step 1, step 2, and step 3. Step 1 is to create an X and a Y chart. You say, Ms. Johnson, what's that? It's exactly what we did in example 1. We're going to create an X column, a function column, and a Y column. Okay? Now, you'll notice in example 1, does it tell us what values to use for X? Yes or no?
Yes.
In letter A, it tells us what value to use for X. Look at the problem. No. All the problem says is f of x equals 3x minus 2. So here's what you're going to learn and memorize. When we're graphing a linear function, we are going to use negative 1, 0, and 1. See, technically we can pick whatever values we want, but I'm going to try to keep it as simple for you as I can. So negative 1, 0, and 1. We've got a negative number covered, we've got a 0, and we've got a positive number covered. And do you know what's going to happen when we use a negative 1 and a 0 and a positive 1? Our ordered pairs are going to stay small. We're not going to be trying to graph some large, outrageous numbers. Okay? So this is what you need to memorize. When you are graphing a linear function, you're automatically going to use negative 1, 0, and 1 as your domain. All right? So let's work on step 1 and 2. Let's create an X and Y chart. Okay? We've got our X column. We know we're going to use negative 1, 0, 1. Let's go ahead and we're going to change f of x to y this time. So 3x minus 2. And of course our output column will be our y column. So y equals 3 times negative 1 minus 2. Y equals 3 times 0 minus 2. And y equals 3 times 1 minus 2. All right. Again, we multiply before we subtract. So let's talk through these. What's 3 times negative 1? Negative 3 minus 2? Negative 5. 3 times 0? 0 minus 2. 3 times 1?
3.
And 3 minus 2? 1. Now, the last thing we're supposed to do is plot points and draw a line. You say, Ms. Johnson, what points are you talking about? Our X and Y coordinates. And where are we going to pull X and Y coordinates from? From the chart we just made, okay? So over to the side, we're going to list our 3 ordered pairs. What's the first one on this chart? When we plugged in a negative 1, a negative 5 came out. That is our first ordered pair. Hayden, what's our second ordered pair?
0,
0, negative 2. All right. And Timothy, what's our third ordered pair? 1 and 1. Now we graph these, okay? This should hopefully be just a quick review. When I want to graph negative 1, negative 5, I start in the middle, and which direction do I go first? Left to negative 1 and then down to negative 5. Make sure you label the point, okay? I don't want to have to sit and figure out what you've done, so just label the point. All right, 0, negative 2. Now the x-coordinate is 0. Do I go right, left, or nowhere on the x-axis? Nowhere. But for negative 2, I go where on the y? Down to negative 2. So the ordered pair is 0, negative 2. And then for 1, 1, starting in the middle, I go where?
over,
Right 1 and up 1. Okay, so up 1. Don't tell me over, only because I can go over to the right or I can go over to the left. So just be very specific, okay? Right 1 and up 1. And then the only thing left for me to do is draw a line through my points. Notice what I'm putting on the end of my lines. What am I putting on the end? Arrows. That matters. That is part of the answer that I'm looking for. Draw the line through all 3 points and put an arrow on both ends. Now, you know there's always an exception to the rule. And I like to show you those exceptions so that you know what to do when you encounter this type of a problem. Okay? Most of the time, we are going to use -1, 0, and 1. But what happens when we have a problem that looks like letter B? What are we going to be multiplying our x by? A fraction. Now, if the stuff I say in the next 2 minutes makes no sense to you, please feel free to just use -1, 0, and 1. However, if you do that, you're going to have fractions in your ordered pairs. Does anyone really love to graph fractions? No. So what I'm going to do is I'm going to teach you what to do when the number you're multiplying your x's by is a fraction. I'm going to show you what to do so that you can get rid of the fractions and you're going to be plotting whole numbers. All right? What is the denominator of this fraction? 4. So I would highlight it, I would circle it, do something. And then here's what I want you to do. Let's make a note over to the side that says use the denominator. Use the denominator for 2 of your numbers. Okay, so use the denominator for 2 of your numbers. Now, of the 3 numbers I gave you to use, which one do you think we're going to keep? The 0. Okay, we love 0. 0 is going to cancel that fraction out and we're going to be in good shape. So when I say use the denominator for 2 of your numbers, use it for the negative number and use it for the positive number. So let's go make our chart. We've got our x coordinate. We're going to keep our h of x this time. It equals -3/4 x minus 1. And of course our final column is our h of x. All right, so we're going to use a -4, a 0, and a +4. So you see how we took the denominator, we made it negative, we kept 0, and then we kept the +4. Let's plug these values in. H of x is equal to -3/4 times -4 minus 1. H of x is equal to -3/4 times 0 minus 1. And h of x is equal to -3/4 times 4 minus 1. Now, what do you notice right away about the 4's in your first function? They're going to cancel. You've got 1 in the denominator, and the whole number is technically the numerator. So, be careful. The 4's cancel, but this is a -1. So, you've got a -3 times a -1, which equals a +3. So what's 3 minus 1? 2. What's -3/4 times 0? 0. Hallelujah. Thank you, Jesus. What's 0 minus 1? -1. And again, the 4's are going to do what here? Cancel, and you're left with, be careful, -3 minus 1, which is -4. So our ordered pairs are -4, 2, 0, -1, and what's the last one? 4, -4. So we plot them. From the center, we go left to -4 and up to +2. Make sure you label it. 0, -1, we stay in the middle. We go down to -1 and we label it. And 4, -4, we go right to 4 and we go down to -4. And of course, we label it. What's the last thing we're supposed to do? Draw a line as straight as we possibly can. Put those arrows on the end, and we are done. Now listen, if you get any shape other than a line, you've done something wrong. Go back and find your mistake. If this ends up looking like a V or like an S, you've done something wrong. Go back and find your mistake. Last but not least, we have example number 4. Now, I want you to I'm going to try to make this as simple as possible. This is our word problem for the day, all right? It says, let f of t. Now, I know we are used to seeing f of x, but sometimes they're going to put a different letter in the parentheses and it's okay, especially since it tells us as we keep reading what that T represents, all right? But start with F of T. Let F of T be the outside temperature, all right? So F of T is the outside temp. That's what F of T is telling us. All right, it says T hours after 9 a.m. So the T equals, okay, hours after 9 a.m. All right, if you're not careful, this is going to be real confusing, but I'm going to try to make it not confusing. So we've got two parts. We've got F of T, or what letter can we replace F of T with?
Y.
Y. And we've got T, which we typically know as X, right? So you've still got an X and a Y. It's just F of T and T, all right? So it says, explain the meaning of each statement. Now I want you to look at letter A, all right? What are they, instead of a T right here, they have a 4. So what do you think they're telling us that T equals? 4. All right? And even though it says F of 4, it also could say F of T. So what are they telling us F of T equals? No, you're not listening. You're still telling me about T, just T. I want to know what F of T, the whole function. Why? 75. Okay, 75. So you see how there's two pieces of information here. There's just T, that's given to us in the parentheses, and then there's F of T, which is given to us on the other side of the equal sign. Now we have to interpret this, all right? T is the time after 9 a.m. So if the time is 4 hours after 9 a.m., what time are we talking about?
1 o'clock.
At 1 p.m., it's, what did F of T? Look at what we wrote down. F of T is the outside temperature. So at 1 p.m., it's 75 degrees Fahrenheit. Look at letter B. We've got a 2 in the parentheses. So they're telling us this time that T equals what? 2. And they're telling us that F of T equals 70. So interpret that. What are they telling us? At 11 a.m., because remember, it's time after 9 a.m. So 2 hours after 9 is 11 a.m. At 11 a.m., it's what? 70 degrees Fahrenheit. And that is lesson 3.3.